Good morning, students, and I am with the chapter Chemical Reaction and Equation. We already have learned about this chapter in previous classes 9, 10, and probably in 8. And I hope that you have not forgotten the things you have studied in your earlier classes. So, without any delay, I want to say you we will learn in this chapter a special kind of reaction, just like redox reaction. Redox reaction means reduction and oxidation, as well as we will learn about the different kind of special reaction like substitution, photochemical reaction, double displacement reaction. I think you have not forgotten about the reactivity series. Do you remember reactivity series? This is reactivity series, and now I have the question for you. What is chemical reaction or chemical change? So the chemical change, that involves a process that involves rearrangement of molecules or ionic structure of substance as distinct from a change in physical or nuclear. Why I am saying about involvement of rearrangement of, but I'm not saying about formation of new substance. Obviously there is a formation of new substance, but the entity keeps itself intact, just like that. See in this reaction, magnesium plus oxygen, magnesium oxide. Here is magnesium and here is also magnesium. It is only combined with oxygen. And in physical change, you can see in physical change, a wood is being cut in two halves. It remains wood. No rearrangement of molecules or ions. But if you see in nuclear reaction, obviously there is two types of nuclear reaction, that is fission and fusion. Fission meaning of fission is breaking down and fusion is adding up. Do you know about radioactive elements? Radioactive elements are such elements which can break down itself and form two or more distinct substance. See here, nuclear reaction, it is fission reaction. Here it is uranium 92-235. When uranium is bombarded with slow moving neutron, it forms an unstable compound and further it breaks down into barium and krypton. And because you see here, now uranium is converted into barium and krypton, unlike what we have seen here in chemical reaction. Here magnesium combines with oxygen and forms magnesium oxide, but there is no newly entity forms here. There is only combination, means exchange of ions, sharing of ions, and formation of new molecules, unlike nuclear reaction. Just see here downward, just drag it down. Let's check here. In this nuclear reaction, you can see again I am repeating the words. Uranium is a radioactive element. When it is bombarded with slow moving neutrons, it forms unstable compound, that is uranium 92-236, and now it further breaks down into barium and krypton with 3 more neutrons. You know, this reaction is also used in atomic bomb, and that kind of reaction is totally uncontrolled chain reaction. Now moving forward, here is fusion reaction. Okay, here is fusion reaction. This is actually wrong, written over here. Fusion, not fission, that is fusion. Okay, so you can see here isotope of hydrogen, that is deuterium and tritium. It combines and forms helium, and evolution of high amount of energy. You can see here 17.59 mole electron volt, and 1 mole electron volt is equal to 1.6 into 10 to the power minus 19 joule. Just note it down. Okay, now chemical equation. The question is that what is chemical equation? See here, A chemical equation is the symbolic representation of chemical reaction in the form of symbols and formula, wherein reactant entities are given on the left side and product entities on the right side. And the first chemical equation was diagrammed by Jean Berquin in 1615. No need to remember this name, but for general knowledge you can remember it. Okay. So now the question is that why do we need chemical equation? The description of chemical reaction is quite long in the words. It can be written in shorter form. Simplest way to write it in the form of word equation. You know, if we use in the simplest form means formula form, it takes the less time. It becomes less lengthy and you can write it again and again. If suppose that if you're writing in the words, magnesium reacts with oxygen and forms magnesium oxide. Again and again if you write in the words, it takes time and it is also frustrative. So that is why we use formula. Now see here. We have written magnesium plus oxygen, magnesium oxide, and you know, when we write in the formula just like that, suppose we write here like magnesium plus oxygen, that is magnesium oxide. How much time it takes? Lesser than 1 minute. So see, here you can see the arrow here. Single side arrow shows the direction of reaction. Suppose you know guys, uh, there are a representation of arrow like this also. This is called reversible reaction. We will discuss it later on in the next chapter. But first, we are here to learn about the types of reaction, the symbols, the origin of the symbols. See here, helium. He, helium, atomic number 2, and you can see here, helium is named after astrological or mythological. It has origin astrological and mythological. After Greek, Helios means sun's god. Now we talk about lithium. Lithium. Start with, see here, lithos. Lithos means stone. Stone from Greek. It was discovered from minerals. Means if someone asks you, okay, what is the origin of name lithium, you can say it is from Greek word from lithos. The meaning of lithos is stone, and stone is obviously a mineral. Okay, now let's move on to the next topic. Balance chemical equation. We have already learned about how to balance the equation, and the question is that why do we need balanced chemical equation? In class 9 we have learned about the conservation of mass. What does the conservation of mass says? The conservation of mass says that the mass can't be created or destroyed. Okay, so the mass remains same. If you consider a chemical reaction or chemical equation, so the total mass remains conserved, means the left side of reaction arrow and right side of reaction arrow, when you combine these masses, they are equal. That is why we balance the equation first, because we need to follow the conservation of mass theory. Now the types of reaction. The first type of reaction is combination reaction. Combination, it is very clear with the name. Combination means combination reaction. See this reaction. Calcium reacts with water. Actually calcium oxide, that is quicklime, reacts with water and forms calcium hydroxide. See here, calcium slacked lime, calcium hydroxide, and it evolves with high amount of energy. You know guys, this kind of reaction is also called exothermic reaction. Calcium oxide combines with water and forms single product, and such reaction form with two or more reactant. Here you can see two or more reactants makes one product. Okay, also some examples here you can see. The burning of natural gas. The natural gas, methane, Mars gas is also called natural gas. Methane gas, when it is burnt in free air, it forms carbon dioxide and water. Also there is amount of energy is released. It is also a special kind of reaction, and earlier I just have said you the liberation of heat, liberation of energy, this kind of reaction is called exothermic reaction. You see here. Okay, respiration is also exothermic reaction. We know that what the food we eat, at first it converts into glucose, and glucose burns in the presence of oxygen and forms carbon dioxide, water, as well as it gives you energy to carry out your work. The decomposition reaction. The decomposition of organic materials, also known as exothermic reaction. Biogas is produced with the help of bacterial decomposition. You know, uh, you can see when the garbage is thrown over nearby you, you can feel much warmer atmosphere there. That is only because of decomposition evolves with some sort of energy, some sort of heat, and that is why decomposition reaction is also called exothermic reaction. Its nature is actually exothermic. See, now we come to the decomposition reaction. Decomposition reaction. In this kind of reaction, single reactant breaks down into simpler product. See, iron sulfate, when it is heated up strongly, it forms iron oxide as well as sulfur dioxide gas as well as sulfur trioxide gas. You know the special character about sulfur trioxide gas. It combines very fast, it combines very rapidly with atmospheric water. You can say when there is atmosphere is so damp, when you burn, when you burn when you burn some organic substances like wood, it gives you sulfur trioxide gas. When it combines with water, it forms sulfuric acid. See here. SO2 is a colorless liquid. It can also exist as ice or fiber-like crystal or gas. When SO3 is exposed to air, it rapidly takes up water and gives white fumes to form sulfuric acid. You know, this reaction is carried out in acid rain. And see also. Here, calcium carbonate, when it is heated strongly, it forms calcium oxide as well as carbon dioxide gas. Here, it's also a decomposition reaction. Lead nitrate, when it is heated up, it gives you lead oxide as well as nitrogen oxide as well as oxygen gas. Now we will learn about a special kind of reaction which is called photochemical reaction. Why do we say it photochemical reaction? The meaning of photos is light. Silver chloride is, when exposed in air, it decomposes into silver as well as chlorine. This kind of reaction is called photochemical reaction. Silver bromide, just like that, silver chloride, silver bromide, when exposed in the sunlight, it gives you, it decomposes into silver as well as in bromine. The above reaction is used in black and white photography. ये वाला रिएक्शन जो हमारा फोटोग्राफी में यूज होता था, रोल कैमराज में इसका यूज किया जाता था पहले. In above reaction we can see the light was given to perform reaction. So this kind of reaction is called endothermic reaction because we are inputting the energy. When we input energy to perform any kind of reaction, this is called endothermic. Endothermic means inputting energy. When you input, just like your mom is cooking food, she is inputting energy to perform her activity. This kind of reaction is also called endothermic reaction. Us now we will discuss about the displacement reaction. Displacement. Clear with the name? Before that, you need to learn about the reactivity series. If you are very clear about reactivity series, you will have no problem to understand this topic. In this type of reaction, highly reactive element displaces less reactive element from its solution. Like iron is more reactive than copper, so it will be able to displace copper from its solution and forms iron sulfate or ferrous sulfate. See again, zinc is more reactive than copper, so it forms zinc sulfate and copper displaces. Again, for the lead is more reactive than copper, so it displaces copper from its solution. So from this chapter we have learned about the different kind of chemical reaction. Still we need to learn more, and we will discuss more about this chapter in next video. Stay tuned, stay safe. Goodbye.